The final equation on your Unit 1 datasheet is this one, V equals F times lambda, and lambda stands for wavelength, so V is the speed, F is the frequency, and lambda, this Greek letter, is the wavelength. Again, you don't get given the unit, so please remember that the wave speed is in meters per second. The frequency is in something called hertz, which is a capital H with a little Z after it as the symbol, and the wavelength is given in meters. That makes sense. If our speed is in meters per second, then we should have our wavelength in meters as well. The frequency is the one that's a bit funny. That's the one that's in hertz, H-E-R-T-Z, or capital H, little z. Make sure you actually know what the wavelength is. It's from the bottom of one wave to the bottom of the next, or it'd be the same distance from the top of one wave to the top of the next. It's not just top to bottom though, so make sure you have a full wavelength if ever you're asked to describe it on a diagram. The amplitude is only halfway up the wave though, so just be careful. Amplitude is going up and wavelength is going from the top of one to the top of the next. If you get a louder sound, you have a bigger amplitude, so you have a higher amplitude. If you have a higher pitched sound, so one that sounds much higher, then that is going to have a shorter wavelength and therefore a higher frequency. In this example here, it tells you the speed is 3 times 10 to the 8 meters per second, and the wavelength is 2.5 times 10 to the 2 meters. So we don't need to do any conversions. We've got the meters per second and we've got the meters. They're asking us to work out the frequency. Using the correct equation, that's the one that we've just looked at. But you might have noticed that actually that's not going to help us calculate frequency in its current form. We want the F, the frequency, so we do need to rearrange it. If it helps you to think about this in a formula triangle, speed equals frequency times wavelength, and if you want frequency, then what you need to do is you need to do your speed divided by your wavelength. So if our frequency equals our speed divided by our wavelength, then that is equal to our speed of 3 times 10 to the 8 divided by 2.5 times 10 to the 2. If you're not very familiar with what these 10 to the 2 and 10 to the 8 mean, 3 times 10 to the 8 just means that you add 8 zeros afterwards. And 2.5 times 10 to the 2 means you just move the decimal place once, twice, to give you 250. So it's this number here on the top divided by 250. And that's equal to 1,200,000. And don't forget your units at the end. This is in hertz because it is our frequency.